Hello everybody, welcome back to my new video. Today we are going to design the stainless steel cylindrical tank in SAP, okay? It's gonna look like this. So without further ado, let us start. At first we have to open our SAP file. So I want to show you something. So our cylindrical tank is this one, and the only thing that were provided was like the volume of cylindrical tank, and it was 12 meter cube, and the diameter of cylindrical tank was 2 meter. So from here we have to find the height of the cylindrical tank. So we know the volume of cylindrical tank is equal to pi into radius squared into Yachts. So we have the given volume 12 meter cube and diameter as 2 meter, so radius becomes 1 meter. So we just keep the value h is equals to 12 divided by pi into r square. So since r is radius is 1, so it doesn't matter the square of the radius. So we got the height of 3.82 meter. So height is equal to 3.82 meter and diameter is equal to 2 meter. This is our value we are gonna put in our analysis. So file, new model, and then go to cells. So the cylindrical height we get was 3820 millimeter and radius was 1000 millimeter. So number of division is like how many division you want in z-axis. So 1 2 3 4, that's why it says 4, and 16 is the 16 number of division. So for in our case I just want the symmetrical division of the numbers, so I just do 24, and then okay. So after doing that, our cylindrical tank look like this. So here if we go to the bottom, let us define some more things. So go to define material. So here we can see that it can only do for concrete and then steel, but we want stainless steel. So how to do it? So it's a bit confusion. So let us add new material and then go to region. I am doing it for Europe. Material type is steel. Standard, let us say user, because if we choose this standard, then our stainless steel doesn't fall under this one because our stainless steel is 316L. So I will just change this to user and then okay, and then this thing will pop up. So I will change steel as stainless steel, material grade S316L, and then uh, unit weight per volume. So unit weight per volume of our stainless steel is, if we do this into kg, so unit weight per volume is mm, is tentatively around 8000 kg per meter cube. So you can google this value, 8000. Actually it's like 7900 something, but let us keep 8000, and then you can change this into kilonewton mm or kilonewton meter, or let us check newton millimeter. Yeah, this should be nice. So modulus of elasticity, it's gonna be around 2 GPa, 200 GPa. So it's this much. Poisson ratio is about 0.3. Coefficient of thermal expansion is 1. 1.16 into 10 to the power minus 5. So, and the minimum yield stress is gonna be 170, and minimum tensile stress is gonna be around 485. So here you can just do 170 and 485. Okay, so we have made our new material, stainless steel. So okay, so after that go to define, and then again section properties, area section. So in area section, because we need area on the top of the stainless steel and on the bottom of the stainless steel, so add new section. Mm, let us name it as area, sail thin, type in type sail thin, and thickness. Our thickness of cylindrical steel plate is gonna be 4 millimeter. 4 millimeter. Material type it's gonna be stainless steel. Okay, and then we cannot delete, so area. Okay, now we can assign the area. So select this one, drop poly area, and then here select area, and then we have to like figure out on which plane we are on. So xy plane at z is equal to 0. So we just need to click on every single point, and we have to be careful while selecting these points. And then press enter, and then we can see it has been done. Now we have to go to, so if we click up arrow, then it will just go from 1 2 3 4 to up, but if we directly click on down arrow, then it will directly go on our last plane 3820. So here also we need area, so I will just click on every single point. So our area section has been done. So let us check our model once in extrude view before we proceed. So general option, extrude, and let us fill the object. Apply. Sorry, we have to do this for 3D part. So general option, extrude, fill object, apply. Okay. So this is how our model is gonna look like in extrude view. Okay. So now we can go to the standard view. After that we have to go to define, load pattern. So dead load is the self weight of the stainless steel tank, and then we need so this one is for potassium hydroxide, so KOH pressure. So KOH is like the chemical name of potassium hydroxide, type dead. Let us do self weight multiplier 0. Add new load pattern. Okay, so we have added our new load pattern also, and then after that let us directly go to uh, after that let us go to our z plane at z is equal to 0, and then I will try to do the standard with field object, apply. Okay, so we need to give restraint, so assign joint restraint. So depending upon your data obtained, you can just restrain your tower. So for me I am doing like this, apply. Okay, so our base has also been restrained. After that we have to go to once again assign and then joint pattern. Here it is one of the most important thing while designing the cylinder. So here whenever we fill our cylindrical tank with any other liquid inside it, so let us say the height is yachts and the height from, so this is the our liquid level, so height from this to this is z, so the remaining height is gonna be yachts minus z. Yeah, and the pressure distribution is gonna be like this, always maximum at the bottom and zero at the top. Pressure distribution, whether it's gonna be water or whether it's gonna be any other liquid inside our cylindrical tank. So pressure is equals to rho g yachts, density into g into yachts. So density of our potassium hydroxide solution is 2044 kg per meter cube. So if there is water, then you can use 1000 kg per meter cube depending upon what we get. So 2044 into 9.81 into 3.82 minus z. So it becomes 3.82 minus z. So if we multiply density by gravity, then we can get in Newton. So it becomes 20.052 kilonewton, and then the value. So if we multiply, the final product is going to be 76.59 minus 20.052 z. So this is our final value. So we are going to apply this value into our SAP model. So minus 20.052 z. Yeah. So here, if you see ax plus by plus cz plus d, so it's going to be in our z axis because this is our z axis. So it's going to be minus 20.052, and then the constant value was, sorry, 76.59. 76.59. Replace the value, existing value. Okay. But that's wrong because our unit is should be kilonewton meter. So once again go to assign joint pattern. So look, if we don't consider the things, then there will be mistakes. So 20.052 comma. Okay, so after that select all your cylinder and then go to assign joint pattern. So now everything seems okay, so apply. Okay, now if you check your cylinder, then we can see the stress distribution like here starting from 0. So if we go on the bottom, it should be 76 point, the maximum value 76.59. So it will just keep on like uniformly distributing the values to all the cells that you have made. And then after that what we have to do is again we have to go to assign and then area load and then surface pressure, because we are gonna provide the surface pressure from potassium hydroxide solution to the stainless steel tank. So surface pressure, load pattern is QoS pressure, and here on the bottom, because always on the bottom there is going to be the maximum pressure from the liquid. So here pressure by joint pattern, and then let us do multiplier as 1. Okay, after that we have to select all these things, assign area load, surface pressure, everything is okay. So apply. Okay, so as we can see in this model that surface pressure is applied. If you see this blue tick, then it is going from inside to outside, so surface pressure is applied from inside of the water to the stainless steel tank. So it means our model is correct, because sometimes if the area is not correct, or if our notation is not correct, then we can get this blue value from outside to the inside, so we have to be careful on that. Now our model is correct. So after that, just click on the run button. We don't need to run the model because it will take a bit long time. So run now. Let us make practice, save. I'm sorry this video is taking a lot of time, but if we want to learn, then we have to learn from the scratch. Yeah, that's why. So our model look like this, and then if we click on so forth. So if we go to design, steel frame design, and then go to view revise preference. So here you can change your design code based on what type of code you are going to use. Okay, so in our case I am using SP16 AISC. So let us change it to Euro code because it's on Europe. So country, it's gonna be Norway, and the other factor, if you want to change, you can change here. So just to OK, and then design, steel frame design. So this one is done. So directly click on this sales plus QoS pressure, and then component type. From here you can determine what type of value you want. So let us just to apply. Okay, so from here we can see the stress distribution of our QoS solution into this cylindrical tank. So you can see the pressure is increasing at the bottom, maximum here. So you can just analyze depending upon your project requirement. So guys, thank you for watching. This one's for today, and if you have any comments, then please write in comment section and I will try to explain it based on your questions. Thank you. Take care. Have a good time.